Hey everyone, so in this video we're going to take a look at how to take our single enemy combat system and turn it into a multi-enemy combat system. Before that, we are going to do a little bit of code optimization courtesy of TechDave99. He came up with a solution to the question I posed in the last video. So in the last video, I said I wanted to get rid of the switch section. I wanted to have something better because for every single enemy, you are going to have a case. And depending how much you do based on that case, you are going to have hundreds, if not over 1,000 lines of code just choosing what is going to be instantiated. So my theory was that there was a way to remove the constant, that is the first argument, from the instantiate statement and replace it with a variable. So rather than saying if case 1, then enemy 1, if case 2, then enemy 2. Instead, you'd have a single instantiate command that has a variable rather than constant, and that is what TechDave99 delivered. So in the top section here, I had some transform variables, enemy 1, 2, 3, 4. You can delete those. There was also a number that was another variable that was being used for a random number. You can eliminate that. We're just going to replace it with another one. Okay, so what are we replacing those lines with? We're replacing it with this one, public game object brackets enemy and private int random enemy. So this is going to be used for the random number generating. But this is where the main difference is. So public, this makes it accessible in the inspector. That's very important. You'll see that in a minute. Game object, so he changed the type. We were using transform. He switched it to game object. That's fine. There's just one little tweak we're going to have to do to the code since it's game object rather than transform. Square brackets, and then the name enemy. This is the name of the variable, which is the same that I was using, enemy 1, 2, 3, 4, so on and so forth. So public game object brackets enemy, private int random enemy. If we save this, watch what happens. We come to our GM object, which is the script that is attached to, and now you have this. So here is the array. Sorry. Oops, just 5, not 55. And it creates 5 positions. And now you just drag and drop the enemies to them. So I don't have any particular preference right now as far as which enemies instantiate where, so you can just put whatever ones you want. And that now gives us our enemies. So what else do we have to do? Not much. In the start section, just 2 lines of code. So random enemy, so again, this is this variable, random.range 0.enemy, 0, enemy.length. So this is very similar to what I was doing, starting at 0, but I think I might have been starting at 1. You have to start at 0 because the first position is 0. So you see how it says element 0? So this is position 0 in the array, position 1, 2, 3, 4. So the first one is 0. Yes, that's just the way it works. So random.range, start at 0, and then go to the length of this array. So you no longer have to manually change that number. As the length increases, this will increase. So enemy.length will automatically bring you that outer limit. And then instantiate, and this is like what I said I was looking for. I wanted to have a variable, not a constant. So instantiate enemy bracket random enemy. So the numbering actually comes out very similar to what I was doing where I had the variables enemy 1, enemy 2, enemy 3. This comes out very similar. Starts at 0, but again, it's enemy and then what position? Position 1, 2, 3, 4. So as you can see, this is way more concise. You're going to eliminate possibly 1,000 lines of code depending on how complex that switch statement got. I usually save optimization towards the end, but we really didn't want to go down that route. So like I said, that very often you just put something in place as a proof of concept. In this case, because of how much we're going to do, really don't want to keep that switch statement in place. So we've now replaced it with this. So literally, what was it already up to over a dozen lines of code for the 5 enemies. Now it's just 1 line of code. So well done, TechDave99. This is exactly what I was looking for. Instantiation based on a variable, not a constant. So let's run this. I'll explain what these 2 lines of code do in a minute. And if I did not forget anything, we should now have random enemies. Yep. Okay, so perfect. Now what do we want to do? So now we've gotten the optimization behind us. Now we can move forward with the multiple enemies. So what we're going to do is we're just going to rinse and repeat this. Actually, both of these. What we're going to do, we're going to generate another random number. Actually, let's just repeat this one. And there might be a more concise way of doing this, but in this case, it's 3. There'll never be more than 3 enemies on the screen. So in this case, I'm not worried about optimization. Okay, so we generated a random number, and then we instantiated at 0, 0, 0 because we said the default location of all the enemies are 0, 0, 0. So like if I click on this guy, 0, 0, 0. Okay. Now we're going to generate another random number, and we're going to instantiate another enemy, but this time we have to put in all 3 arguments because, as I said, you only have to put in 1 argument if you're using the enemy's position and rotation. Well, we can't use their position because they'd be on top of each other. So we're generating a second random number, and now we have to put in that second and then therefore third argument. So what we do, we say, actually, we don't need the random enemy -1. Sorry, I was kind of messing around. So instantiate enemy, random enemy, but now we have to say where it's going to be positioned, -8. So it's going to be positioned to the left of the screen. And 0, 0, again, everything is instantiating at Y0 and Z0. And since we declared this, we also have to declare the rotation. So enemy, random enemy, and this is what I was talking about. Because I was using transforms, I didn't have to do this. Because the new method is using, probably shouldn't use the word method, but the new approach is using game objects. So we now have to drill down. We're drilling down from game object to the transform component, and then within the transform component is rotation. So enemy, bracket, random enemy. So again, this is just referencing this, but now we're drilling down to the rotation. So what is being instantiated, where it's being instantiated, and the rotation of what is being instantiated. And now it's just rinse and repeat one more time. So again, imagine if we were doing this with the switch statements. Now we'd be up to 6 per switch choice. So yeah, if you had 200 enemies, over 1,200 lines of code, press the break line for each one. So now you're talking, what, 1,500? So much more concise. So in other words, this is rinse and repeat. We are generating a random number, instantiating, generating another random number and instantiating -8 to the left, and then generating another number and then instantiating +8 to the right. So symmetrical, dead center, 8 to the left, 8 to the right. The reason why there was a plus and minus there, I was trying to avoid generating another random number, but then you have to kind of create these filler positions so you don't go out of bounds. And I'm like, something, generating 3 random numbers is good enough. So you're generating 3 random numbers and instantiating in 3 positions. And then, like I said, we're going to leave this for now. I'm not too worried about the environments at the moment, but we will take a similar approach that we did with this. Okay, so now 3 enemies should spawn on the screen. So let's watch that to make sure I didn't break anything there. Now, one of the good things about this approach is you might get duplicates or you might not. So this way, and I can think of games like Dragon Quest and things like that, where sometimes you would have all of the same enemy, sometimes it'd be one of each. So we'll just run this again. So that time we got 3 different ones. The bear looks a little tiny. Okay, so we now have the ability to, well, in addition to making more concise code, we now have the ability to have multiple enemies spawn on the screen. So now we need to be able to choose which enemy attacking. So that means we need to add new functionality, and we're going to use a good old left mouse click. Yes, so we're not really working too much on the UI at the moment. We're just going to use a left mouse click, which we'll probably eventually replace, but it's good for now. So for a left mouse click to work, that means you need a collider on the enemy and a script to detect it. So these objects already came with colliders, okay? Our enemies already came with colliders from the creator who made them. Now that means they just need a script, and I already did drag and drop a script onto it. So let's take a look what that script says. So Enemy conscript is put onto the enemy object. So at the top, private float, this is important. We don't want it to be static. We want every single enemy to have its own unique enemy HP variable. So private float enemy HP equals 15. You can use whatever number you want. I just wanted a number so that it took 3 times for it to work. Private string current target is equal to no. So this is going to track which object is going to have this be done to, because remember, this script is attached to every enemy, so you need a way for the particular enemy that's going to be affected to realize that it's the affected one. So I'm going to skip the update section because it won't make any sense until we've done the on mouse down. So on mouse down does 2 things. Battleflow.selected enemy. So I created a new variable in the Battleflow script. So selected enemy, it is a vector 3. So I'm grabbing the X, Y, and Z coordinates. Again, we said that this is all driven by the fact that objects will have consistent placement. So in this case, the X is -8, 0, and +8. So public static vector 3. In this case, we want it to be static because we want the different scripts and different objects to be able to access this. So if I click on an enemy, selected enemy is equal to transform.position. In other words, this variable is set to the value of the position of the object this script is attached to. Well, this script is attached to an object that's either at -8, 0, 0, 0, 0, 0, or +8, 0, 0, 0. It's grabbing one of those depending which one's being clicked on. Current target equals yes. So what this does is this variable is only true for the object that you've clicked on because it is private. It's not public and it's not static. It's a private variable. So only the one that you've clicked on has that value changed to yes. So you've clicked on that variable. You've clicked on the object, you've selected the enemy. So what gets done with that information? Again, we're going to skip this for the moment. We're going to go to our caster section. I don't think I changed much here. So we have the transforms for the spells. We already have the place the you're pressing the key down for something to happen, and we're instantiating the spell. Now, we were instantiating it at 0, 0, 0. Can't do that anymore. Why? Well, because we have 3 of them. We now need to know where it's going to be instantiated. So we're going to instantiate, I'll get back to this in just a second. We're going to instantiate instead the fire attack object, but we're going to instantiate it at battleflow.selected enemy. Remember, we created a new vector 3. That vector 3 is set to the position of the object you click on. So we're saying instantiate it there. So rather than instantiate it at a constant 0, 0, 0 or 0, 0, -2 in this case, we're going to instantiate it on the position that has been selected. And again, we're using the rotation. So this is really the only thing that's changed. Rather than a constant, it's been changed to a variable. Now, why am I doing this? Why am I moving the .z, which is the depth? Why am I minusing 1 from it? Well, because I want it to be in front of the enemy. So as you're traveling towards the camera, that's actually a negative direction. So I want this to spawn slightly in front of the enemy. So we can't quite use the position of the enemy. We're going to use the X. We're going to use the Y, but we're going to move the Z forward 1. So sometimes you have to tweak these things a little bit. Enemy hit is equal to yes. So now we're going to be able to go back and look to see what the enemy does based on enemy hit equals yes. Again, that's just another variable that was created in the Battleflow script, and again, it's static. That way it can be communicated among multiple scripts, multiple objects. Okay, so you press the number 1 key down. We alter this vector 3 by -1 on the z-axis. We instantiate based on that modified vector 3. We say the static variable is now set to y, and current attack damage is 5. Again, that's another variable I created. It defaults to 0. And this is how much damage is going to be done. So we can save that. And now we look at enemy. So like I said, I skipped over this because it would have made no sense, because I know I try to cover one script at a time, but the actual game flow is from script to script to script, because now this will make sense. Okay, so this script is attached to the enemies. If enemy hit is equal to yes, remember we changed that when you clicked on it. So this is determining which enemy this should happen to. And if current target is equal to yes, which we did as well, then battleflow.enemy hit is equal to no, current target is equal to no, and then enemy HP, so again, this is a private variable, so it is only the HP of this particular object that is being modified. So enemy HP minus equals current attack damage. Now, the reason why I have a variable is this: I want to scale ahead of time, because ultimately, if you have a complex battle system, this number is going to be sliced and diced with buffs and debuffs and all kinds of things like that. So it's good to get the variable in place. So I technically might have been able to do this without a variable, but you want to get that in place as soon as possible. And then get component animator.play damage 01. So the object I'm using, the enemies, they have an animator component, and they have a animation clip called damage underscore 01. Whatever enemy you're using might be named differently. And then what this does, it says if any HP is less than 1, then destroy it. Because remember, we just changed the enemy HP. So if it's equal to 0, then destroy it. In the final version, this will be changed a little bit. Like this would probably have a delay like 2 seconds. And then I would take this and play like a die animation. Okay, so right now it's playing a damage animation. I'd play a die animation. And what this would say is destroy the object, but wait a couple seconds. And the amount of time would be the amount of time it takes for the animation to play. I think that's almost it. Okay, so now we have to, so we've determined what enemy has been selected. We've instantiated. Yeah, I think that's about it. I think that is it, because we already went through the caster, at least for the number 1, the number 2, 3, those are going to just be rinse and repeat. Again, you're going to be instantiating based on location. All right, so I think the fire should work. And if it does, I think that's about where I'll end off. I might do number 2 and 3. But again, these aren't meant to be full tutorials. These are basically a game dev blog. But I want them to be as educational as possible to you guys. So they're kind of more like intermediate or advanced tutorials. So I click on the enemy. I press number 1. And there you go. The fire appeared there, and he had his damage animation. We'll click on him, press number 1, he gets damaged and fired. Let's pick on him again. I clicked, fire again, click, fire again, and he gets destroyed. There you go. And so basically, the only other variable you need to put in place, which we're not going to do right now, is a variable that says how many enemies are remaining. Once that enemy number is 0, then you do like the battle summary, and then you load back into the world. So let's just quickly look at the remaining spells, but it should just be rinse and repeat. I know I say that, but again, I have this issue where I show how something is done, and then some people want to see it again and again and again. It is rinse and repeat. So if you press the number 2 key, all right, this is the old one. So just getting rid of that. And this is the new one. So again, instantiate water attack at the selected enemy variable, vector 3. But in this case, we're not doing the modification because this is under the enemy. So we had to do this modification because we want it to be sitting in front of the enemy. This is under the enemy. Enemy hit equals yes, and then current attack damage is 10, so you're doing more damage. Okay. So let's do that one. So if we do, say, click on, we'll start with him and then press 2. There you go. The water attacks under him. Click on him, 2, and he gets destroyed. So again, you'd probably want to have a death animation there. You might even want to have the damage and then death animation. That is purely an aesthetic choice. You can do whatever you want. And we'll click on him, and we'll press 2, and now he gets damaged. So not bad. I'm not quite sure how long this video is, but that quickly you took a single enemy combat system and you turned it into a multi-enemy combat system. And I said there's only one more variable, but obviously you're going to want to track like XP and things like that as well. I just meant for the overall flow, knowing when the battle is over, you're going to need a variable for that. But yes, you're going to need variables as far as how much gold did you get, what objects did you drop, that kind of thing. But that's all itemization and leveling up, and that's really way beyond the scope of where we are right now. And then for 3, and I'm remarking these out, but you can delete them. I'm just doing this for comparative sake. Instantiate electric attack, new vector 3. Now in this case, we want this to be high in the sky because this is basically like ball lightning that is shooting down. So we want this to be above the enemy. So that Y coordinate is 9. So again, we are starting with the vector 3 of the enemy that's been clicked on, but we're moving it above, and also a -1, we're moving it forward. So let's see. And again, as far as enemy hit and how much damage, so this should be an insta kill. So if we click on the bear and we do 3, it appears above him, insta kill. By the way, there's a light attached to that particle system. That's where that's coming from. I'm not going to get into that. Basically, the particle systems are third party. They are by, I believe it was Arachnor VFX. I did a video on it already, but it's this Magic Arsenal. That's where those are coming from, just as the enemies are coming from downrain DC. Okay, so that is it. I hope that you found this helpful. I am very excited because when you think of turn-based RPGs, that is half of the functionality. Obviously, you have the overworld, you have quests, you have storytelling, but as far as half of the distinct functionality, it's the battle, because that's what it's about. What's your equipment? What's your level and things like that. Battling is such a big part of turn-based RPGs, and in just 2 videos, you now have an almost fully functioning multiple enemy battle system. So like I said, my intention is to turn this into a full game. I have no idea how long it's going to take. We're very early. I suspect the one challenge will be to come up with a narrative that is interesting, because to me, storytelling is very important. Why am I fighting these enemies? Why am I storming this castle? So that will have to fall in place. But I've got a good range of assets that I can use. So, okay, I hope you found this helpful, and please enjoy the rest of your day.